Okay, so this is chapter 1. Our first objective is to be able to understand the basic quantities and idealizations of mechanics. So there are 4 quantities that we're going to use throughout mechanics. The first quantity is length. Now, length is used to locate the position of a point in space, such that we have an idea of the size of a physical system. So for example, it could be a distance from my earplug here to my paperclip. Or it could be even something larger in scale, such as a distance from Pittsburgh to Johnstown. The next quantity is time. So time is conceived as a succession of events, but in statics, all of the principles that we will be analyzing and studying will be independent of time, meaning time won't come into play. All right, the third quantity is mass. So mass is the measure of quantity that is used to compare how one body affects another body. So for example, I could have my box of staples and I could take my Altoids and put it on top, and they interact with one another. So this idea of mass comes really into play, as we know, through gravitational attraction between 2 bodies. It also provides a measure of how much resistance that body will have to change in velocity. So for example, this particular box of staple is much heavier. If I push it with a certain force, it'll resist that motion much more so than if I were to push this smaller box of Altoids with the same force. So mass is a very important quantity. Next would be force. And we're all familiar with force, and we see it as a push or a pull. So it could be, perhaps I have a wall, here's the ground, and I could apply pressure with my hand, that's my hand, and I would be pushing against the wall. So the next concept that we want to be very familiar with and become very good at is to be able to idealize some of the bodies that we'll be analyzing. So in statics, what we're going to assume is that for every body like this Altoid box, this box of staples, we're going to consider it as a particle that has mass, but the size is going to be neglected. Even the shape is going to be neglected. So for example, this Altoid box can now be represented as a particle with a certain mass 1. And this box of staples can also be represented as a particle of mass 2. This process of depicting this Altoid box as a particle and this box of staple as a particle is what is called idealization. Another idealization that we want to grasp is the concept of rigid body. So for example, let's go back to this Altoid box. We know it's made out of metal. We know it doesn't deform that well. If you press it hard enough, it would. But in statics, what we look at it is that this Altoid box, when it's applied a pressure or applied a force, it will remain the shape. It will never change. As opposed to, let's say I have this earplug. This is not a rigid body. If I press it, it changes shape. It changes over a period of time. We won't be analyzing bodies that behave this way. We'll be analyzing bodies that behave this way, meaning the body doesn't change in shape before and after a load application. So far we've looked at the idealization of bodies as particles. We've also looked at idealization of body behaving as rigid bodies. And the next one is concentrated force. This idealization comes into play as follows. Here's my box of staples. It has a particular size. I place a load on it. So in terms of idealization, we say that the load that the Altoid box exerts onto these box of staple is a concentrated force, that it can be depicted this way. I have my Altoid box here. Let's call that M1. It sits on the box of staples. It has M2. And we can say that in effect, it's equivalent to saying that my box of staples has a concentrated load due to the Altoid box.